Okay. Okay, I hope you can hear me now. Really sorry, guys. So we'll just quickly see what we have learned till now. Anyway, thank you for informing me, dear. So I was telling you that we are going to study about analytical chemistry in today's class. Okay, thank you, dear. Thank you so much. It was just a technical error, and thank you for telling me. So analytical chemistry we are going to study in this particular class, half of which I've already taught, but we are going to again revise it. Now, before moving on to analytical chemistry, we will be knowing about certain terms which are important in this particular chapter. तो हमारा first term आता है analysis. Now, what do we mean by the word analysis? In normal terms, the word analysis, it means determining something. Okay, तो अगर मैं chemistry की बात करूं, what do we mean by analysis? Determining a particular chemical component. Okay, so analysis over here, it means determination of, all right, sure, chemical components in a substance. So whichever chemical components are present in a substance, when we determine it, we are said to be doing its analysis. This analysis, it is divided into two categories. First, it is qualitative, and second is quantitative. Okay, now what do we mean by qualitative? What do we mean by quantitative? Let us try to understand it one by one. Qualitative, quality, basically. Quality, that is type. Okay, so in the qualitative analysis, what are we doing? We are just trying to identify the quality or the type of chemical component. Okay, now in the qualitative analysis, what do we do is we identify the unknown component. So what do we do is we go for identification of unknown substance. Okay, for example, I'm giving you a salt and I'm asking you which type of ion or which ion is present in it. You have to determine it. So this is known as qualitative analysis. Next type of analysis is quantitative analysis, that is quantity. So in this type of analysis, what are we doing? We are identifying what is the composition of the mixture that is given to us. Okay, so in this, what do? We go for determining the composition of substance. Okay, for example, any component like H2, as simple as H2, what is the percentage of hydrogen? What is the percentage of oxygen? So that is quantitative analysis. We are just trying to go for the quantity. Okay, then if I give you a salt, for example, I'm giving you copper sulfate. Okay, and I'm telling you, you have to find out which type of cation is present here. So we do various types of tests, and then we find out that it contains so and so ion. Okay, now if I talk about some of these salts of representative elements. Now, I hope everyone knows where are representative elements present in the periodic table. Can anyone tell me which groups contain representative elements in the periodic table? Yes, guys, anyone? So, representative elements, they are present in group number 1, 2, 13 to 17. Okay. Now the salts of these representative elements, they generally are colorless. Okay. The second category we are having is of the transition elements. The transition elements, they are present in group number 3 to 12, and they are having colored salts. Okay, so salts are colored. Okay, now to identify which type of salt is it, which type of ion is present, these salts have to undergo various reactions, okay, with the help of reagents. Now what are reagents? Reagents are the substances which are reacting with another substance in order to let us know which type of salt is present. Okay, so this is how we will be seeing what are the different type of ions, what is the color, what should be the reaction, and how to identify which type of ion is present. Okay, now right now in this particular class we are going to focus on one topic, which is if we are given some of the metallic salt solution. Okay, जैसे कि हमें कोई भी particular salt solution दे दिया है, and we have to identify that which type of salt is present in it, and the reagent that is given to us is sodium hydroxide. Okay, so how to go for that? Okay, so the topic is action of sodium hydroxide solution on metallic salt solution. So this type of analysis, I hope everyone knows that it is the qualitative analysis. What are we doing? We are identifying which type of ion is present. Okay. Now, let us suppose we are having nitrate salt. Okay, just a minute. Not nitrate, calcium salt. Just give me 1 second. Yeah. So let's suppose we are having calcium salt. Okay, how to identify with the help of sodium hydroxide solution? That means a substance that is given to us, it is a salt of calcium, but we of course do not know it, and another reagent that is given to us is sodium hydroxide. So how to make these two substances react, and what should be the product or what should be the identification thing that we are getting in order to know that this particular is a calcium salt. Okay, so, for example, if I am given calcium nitrate, so what would be the formula? It would be CaNO3 whole twice. I hope everyone knows how to go for the formulas. Okay, and when it reacts with sodium hydroxide, the reaction takes place. Okay, kindly let me know in the chat box which type of reaction is it. Okay, what product do we get? We get calcium hydroxide plus sodium nitrate. Now this calcium hydroxide, it is produced in the form of a precipitate which is of white color. Okay, and it is very lightly soluble in the water. So here, because of this precipitate, this white color precipitate, we can say that the salt given to us is the calcium salt. Now we can get white color precipitate with some other compounds also. Okay, but what would be the difference is there would be difference in solubility. Okay, for example, the lead salts, they are also giving a bit of white colored precipitate, but that solution, that precipitate, it is very well soluble. Okay, so you have to be very thorough with the things such as if they are soluble or not, and which type of reaction, if the precipitate, it is jelly like, or it is very simple precipitate like that. Okay, the next thing is, let us suppose we have been given iron salt. Now iron, we all know it is showing variable valencies, okay, 2 and 3. So first, if we have been given ferrous, that is Fe2 plus ion. Okay, so if we have been given this salt, the salt containing ferrous ion, how to identify, or what is the identification if we have another reagent, sodium hydroxide? So let us take the salt ferrous sulfate, that is FeSO4. So this ferrous sulfate, it is pale green in color. Okay, and what would happen if if it reacts with sodium hydroxide? Again, we would be having double displacement reaction. So we will be getting the ferrous hydroxide, which is FeOH whole twice, plus we will be getting sodium sulfate, that is Na2SO4. Okay, this is our precipitate, which means this is the main product which will be telling us which type of salt we are having. Now this ferrous hydroxide, it is a dirty green color precipitate, and the properties are, it is a bit jelly like precipitate, okay, and it is not soluble in water. So the properties are gelatinous, just a second, yeah, so this precipitate, it would be a bit of gelatinous, and it would be not soluble in water. So these are again another identification things, okay, which we can use to identify the type of salts. So this is for ferrous. What if we are having the ferric salt? If the color changes or remains same, let us try to see. So now we have been given ferric, which is Fe3 plus. Okay, if we are having a compound containing ferric ion, let's suppose FeCl3, that is ferric chloride, which is yellow in color, and we made this compound to react with sodium hydroxide. Again, what are we getting? We are getting ferric hydroxide plus sodium chloride. Now this ferric hydroxide would be a reddish brown precipitate. Again, it is insoluble. So we saw in the case of ferrous, we were having green precipitate. In the case of ferric, we are having entirely different reddish brown color precipitate. Okay, so same compound, different ions also we can identify. Okay, next is if we are having copper salt. So everyone knows this is the most common blue color, right? So let's suppose we are having Cu2 plus, that is copper salt. Let's suppose we are having copper sulfate, which is blue in color, and it reacts with sodium hydroxide solution, okay, which is colorless. What do we get? We will be getting copper hydroxide, a precipitate, and we will be getting sodium sulfate. Now over here, the color would be pale blue, and the property is it is insoluble. So we would be getting a pale blue insoluble precipitate, which goes for the copper salt. Okay, the next category could be of zinc salt, that is Zn2 plus ion, or zinc salt. Now what would be happening in zinc? Let's take a salt. This is colorless. Sodium hydroxide, which is again colorless. When they both react, what do we get? We get zinc hydroxide in the form of precipitate. And what do we get? The next one is sodium sulfate. Just a second. Okay, just a minute, guys. And we will be getting sodium sulfate. Okay, so this is again colorless, and here this is a jelly like white precipitate, white gelatinous precipitate. Okay, now students, we saw a white precipitate in the case of calcium ions also. So what is the difference? In the case of calcium, it was first of all not gelatinous, and it was lightly soluble, that is almost insoluble in water, but this is very easily soluble. Okay, so this is how we can differentiate between same colored compounds also. Then we are having lead salt. Pb2 plus. Okay, so let's suppose we are having lead nitrate. The color of lead nitrate is nothing, colorless. And we are having sodium hydroxide again. It goes for double decomposition reaction, and what do we get? We get lead hydroxide and sodium nitrate. Okay, now this is again a white precipitate. In the case of zinc, we had jelly like precipitate, and it is having this chalky white color, and it is also soluble in the water. It is very well soluble. Okay, so this is how we can identify. Okay, now these salts, they were showing the reaction with a common reagent, that is sodium hydroxide. We can also have other reagents, okay, such as ammonium hydroxide, which will be giving different reactions, but the color of the salts, the color of the ions would of course be same. Okay, so let's quickly revise what are the different types of ions we discussed in today's class, and how to identify. So for today, our reagent was sodium hydroxide. Okay, what is a reagent? It reacts with substance to and helps us to identify which type of salt is present or which type of ion is present. For calcium salt, we are getting a white precipitate which is not soluble in the water. Okay, next, in the case of iron, we are having two valencies, right? It is ferrous and ferric. So ferrous, which is Fe2 plus, okay, when it reacts, what do we get? We get a dirty green color precipitate. Okay, it is having a bit of gelatinous texture, and it is insoluble in water. Okay, so ferrous, it is dirty green, it is insoluble, and its texture is jelly like. Next is ferric salt. So it is Fe3 plus. If we take any compound containing ferric salt, and we go for the reaction with sodium hydroxide, we get the compound ferric hydroxide. Okay, this ferric hydroxide, it shows a reddish brown color precipitate which is insoluble in water. Okay, so this reddish brown color, it means that there is a presence of ferric salt. After that, we learned about copper salt. So we take any salt containing copper, and when it reacts with sodium hydroxide, what do we get? We get copper hydroxide, which is a precipitate in pale blue color, and again it is insoluble in the water. After that, we saw zinc ion, Zn2 plus. So when any zinc salt reacts with sodium hydroxide, we get a gelatinous white color precipitate which is very well soluble in water. And this white precipitate, it is of zinc hydroxide. And the last is lead salt, that is Pb2 plus. So if any salt containing lead, it is made to react with sodium hydroxide, what do we get? We get a chalky white color precipitate of lead hydroxide, which is again very well soluble. Okay, so if you are getting same color precipitates, then how to differentiate? You can differentiate by their texture. Okay, if they are having smooth texture, jelly like texture, etc. And second, you can identify or you can differentiate between them using the solubility. Okay, like calcium, it was not soluble. Talking about zinc, it was first it was having a jelly like texture and it was soluble. In the case of lead, it was also soluble with a different texture. Okay, so I hope that this thing is very clear to you. Okay, I hope whatever salts we did for today are very much clear. We will of course be studying about the other salts also in our upcoming classes. So for that, what do you need to do is you need to subscribe to this channel, you need to share these classes with all of your friends, and if you want to have in detail study about these topics, you can download an Academy Learners app and you can join the classes there. Okay, now we are having two type of classes. Okay, that is special and plus. So special classes, they are of course very free of cost, any one of you can attend it. Okay, you just need to proceed with your class and board, etc., and you can attend those special classes. And if you want to have a complete preparation pack, then you can go for your plus subscription. Okay, so guys, whenever you go for your plus subscription, you can use my code RLIC10 and it will be giving you an extra 10% discount. Okay, so I hope you understood everything, and kindly subscribe to the channel and like and share the videos. And also, if you need the PDF, you can join the Telegram channels. Okay, so thank you. We will be meeting in the next class. Till then, please keep learning, keep enjoying. Thank you, students. Please take care.